Welcome to this Yokogawa e-learning module. This module covers the detectors for ADMAG AXF magnetic flowmeters. It is very important to understand the mechanical design of magnetic flowmeters, the functionality of key components, and the design features and advantages. In completing this module, you will learn about the varieties of AXF detectors and their structure, reliable liner and electrode design, and the grounding ring. Let's start with the AXF detector types and their construction. Magnetic flowmeters are designed to satisfy the following specifications as inline sensors with wide application coverage. Wide variety of pipe sizes from 2.5 mm to 400 mm, wafer and flange connections that comply with major world standards, explosion-proof certified models, sanitary connections to meet the requirements of the food and pharmaceutical industries, and a submersible type compliant with IP68 that can endure the underground installations with high humidity or temporal immersion, such as in sewage applications. There are two types of detectors. One is the integral type, which has an integrated amplifier for generating the electromotive force. The other is the remote type, in which the amplifier is separated from the detector. The remote type is recommended in the following: high piping vibration, high process temperature, or corrosive or high-pressure applications. The remote type has economic advantages when considering that flow tubes have shorter lifespans due to harsh conditions. And when the measuring point is in a high location, accessibility to the converter is ensured with the remote type. If reliability of process sealing in the installation of the pipe is critical, the flange type is the recommended. The AXF has a wide flange lineup that complies with various standards. Note that the metal vortex gasket is not recommended as it may damage the liner. When selecting a gasket, please carefully check the note in the general specification or user's manual for the appropriate material. Flange types from 2.5 mm to 400 mm are available for both the integral and remote types. The next topic is the variety of AXF detector types and their structure. This figure shows the design and structure of the detector with its component parts. The following describes these components. 1. Magnetic coils. These are made of copper and generate a magnetic field when electricity is passed through the pipe. 2. Pipe. This is the measuring tube and should not disturb the magnetic field. Yokogawa uses stainless steel or aluminum ceramic as the pipe material. 3. Process connection. This is the connection interface to install the magnetic flowmeter in the piping. 4. Grounding ring. This is used to suppress electrical interference at the installation location for magnetic flowmeters, and they are provided in pairs. The rings are installed upstream and downstream of the flowmeter. 5. Liner. The liner insulates the electrodes from the pipe and prevents the induced voltage from discharging to the pipe. 6. Metal retaining plate. A rugged retaining plate maintains mechanical strength under severe conditions such as with heavy slurries or in a vacuum. 7. Electrode. This detects the induced voltage of the process fluid. When selecting an electrode material, please take into account the chemical resistance in each process fluid as well as the liner and gasket materials. 8. Housing. The housing of a magnetic flowmeter sensor is made of stainless or carbon steel. Details can be found in the specification sheet. 9 and 10. Cables. There are two kinds of cable, an excitation cable and a signal cable. 11. Mini flange. This is available in a wafer or sanitary type. One of the striking features of Yokogawa AXF AXR flowmeters is its robust construction. This shows the strength of Yokogawa AXF AXR flowmeters. In many cases, damage occurs where the neck is welded to the meter body. The AXF and AXR have a cast neck with a reinforcement bar for higher vibration resistance than other vendors' products. The magmeter neck design of other vendors is simple. The neck is directly welded to the meter body without reinforcement. This may result in damage due to piping vibration. Now, Let's examine the reliable liner and electrode design of the AXF detector. The ADMAG AXF has a wide selection of liner materials. It is important to understand the features of each liner material in order to select the best one for each application. The table shows the size and features of the ADMAG liners. PFA has very good corrosion resistance and offers wide coverage such as for chemical, water, and light slurry applications. When the process fluid is an abrasive slurry, ceramic or natural rubber is suitable. Natural soft rubber is the major liner material in the large-size slurry process and the mining industry. Polyurethane is mainly for water applications of up to 40 degrees Celsius. Soft rubber and EPDM can be used for applications of up to 80 degrees Celsius. Yokogawa employs liners made of perfluoroalkoxy resin, or PFA. PFA can form stable layers without pinholes, thus it is the ideal liner material for magmeters, offering superior corrosion resistance at high temperature. PFA offers equivalent heat and chemical resistance to PTFE, and the flexibility to enable injection molding. Injection molding embeds a metal retaining plate in the inner wall and fastens the lining material to the measurement tube. The metal retaining plate adds rigidity to restrict changes in the inner diameter and provides better performance under vacuum conditions than traditional liner designs. In addition, the edge of the measurement tube can be reinforced, delivering good abrasion resistance in slurry applications. Selecting the correct electrode material is also important to ensure reliable and stable long-duration measurement. This is a guide for selecting the electrode materials based on the process fluids. Stainless steel is suitable for water applications, but is not suitable for organic and inorganic acids or chlorides. Hastelloy is suitable for most chemicals. However, it is not applicable for hydrochloric acid, hydroperoxynitrogen oxide, and hydrogen peroxide. Also, we need to be careful with applications including chloride or sulfuric acid. The mixed material of platinum iridium has the best corrosion resistance and can be widely used in most applications except aqua regia and ammonia salt and fluids containing chlorine gas. Tantalum also has good chemical resistance and is used for hydrochloric acid. Titan is a popular material in seawater applications. Tungsten carbide is a hard material that has good slurry noise resistance and is often employed in shield tunneling or mining applications. However, it is a brittle material that can break on low impact. Under such conditions, a concave electrode with general materials is used in many cases to reduce the electrical noise caused by slurry fluids. In order to ensure reliability of the electrodes, Yokogawa employs the optimized electrode design for each electrode material. PFA has two types of electrode structure depending on the application. Standard electrode design is the external type. Reliability of electrodes is very important to the ADMAG series. The internal electrode is a feature of the sanitary types, or for special applications. It is used in such applications as pulp and paper, where slurry fluid can accumulate in the case of external electrodes. The internal electrodes have a kind of seal between the liner and the electrode. Standard electrodes just enter the flout tube through the liner. For comparison, you can also look again at the cross-section of the AXF external electrode. Ceramic liners are widely used when the process fluid is abrasive or has a high level of permeation into the liner. For the ceramic-lined ADMAG AXF, the electrode is a powdered cermet of alumina and platinum. When this is fired into the alumina ceramic liner, the alumina of the electrode fuses into that of the liner. The liner is 99.9% ultra-high purity alumina ceramic with a lined platinum alumina electrode. The ceramic liner is standard 2.5 to 200 mm. Ceramic liner is effective as a countermeasure against penetration in chlorine gas applications. Teflon liner, the most popular liner material, has various features for a wide range of applications. However, it is not suitable for process fluids with high permeation. For example, in applications such as brackish water that includes chlorine, gas penetrates into the liner and deforms it. The ADMAG ceramic liner can be very effective for such application because of its strong permeation resistance and integrated leak-free electrode structure. Let's look at the importance of grounding ring. Grounding rings are used to suppress electrical interference at the installation location for magnetic flowmeters. They are provided in pairs and are installed upstream and downstream of the flowmeter. Grounding rings or grounding electrodes play a very important role in magnetic flowmeters. Because the process fluid has conductivity, the electric potential is different at each part in a magnetic flowmeter. The electromotive force is generated over this electric potential of the process fluid. Grounding rings or grounding electrodes are considered to be zero in the electromotive force. Therefore, no grounding ring is only applicable for installations where the piping is directly in contact with the process fluid, and the piping electric potential is equal to the fluid electric potential. This concludes our module on the detectors for ADMAG AXF magnetic flowmeters. For more information, or to contact us, please visit our website and official channel on YouTube. Thank you.